Hello students, welcome back to Engineers Academy. Do hit the subscribe button if you haven't done it yet. Now we are going to solve this problem which says that the uniform pole has a weight of 30 pound and a length of 26 feet. Determine the maximum distance d it can be placed from the smooth wall and not slip. The coefficient of static friction between the floor and the pole is 0.3. Now the wall is smooth, there will be no friction at B, and we will have the friction at A. And it is said that the pole does not slip, the pole is not slipping. So if the pole is not slipping, the friction at A will be the maximum value, and that will be equal to mu s times Na. So now let's represent all those forces which are acting on the pole. So the wall at B is going to apply the normal force, that is Nb. The floor is applying the normal force in the upward direction, that is Na. And we will have the friction force at A, which is going to act in this direction. If the pole is slipping, so it must slip towards the right, so the friction force will prevent that slipping, so it must act towards the left, and this is Fa. And since we are considering that the pole is not slipping, so we are considering the equilibrium condition. So for that, this Fa will be equal to mu s, that is 0.3 times Na. And now the weight of the pole is going to act at its mid length, so this will be the weight, and this weight is 30 pounds. And let's say that this corner point is, let's say this particular point is point O. So before going to consider the equilibrium condition, we have to find this OB length. So now we have this right angle triangle OAB. This length is not known, only the length of the pole is known, which is 26 feet. So by applying the Pythagoras theorem, we can say that length AB, which is the hypotenuse, this is the length of the pole, is equal to OB square plus OA square. So we are interested to find OB square, AB square, this is 26 square, OB is not known, OA is D square. So now we can say that OB length is 26 square minus D square under the square root. So this OB, this length is 26 square minus D square under the square root. So let me write it here. This OB length, this is 26 square minus D square under the square root. So now we are considering that the pole is in equilibrium, it's not going to slip. So if it's not going to slip, we are going to apply the summation of forces along x, the equilibrium condition. This is our positive x direction. So now as we can see that NB is acting in the positive x, so I will write plus NB. And this friction is acting in the negative x, which is 0.3 times Na. So this is minus 0.3 times Na equals to 0. And from this we can say that NB is equal to 0.3 times Na. And then the summation of forces along y, this must be equals to 0. The upward direction is considered to be positive. So now as we can see that this Na is acting in the positive y direction, and this weight is acting in the negative y. So we will have plus Na minus 30, and this is equal to 0. And we can say that Na is equal to 30 pounds. Now the summation of moment about point A, that must be equals to 0. The counterclockwise moment is considered to be positive. Now this we are going to find the moment about point A. They are not going to produce the moment about point A. So only this NB and this weight, they are producing the moment about that point A. So now this NB is producing the moment about point A in the clockwise direction. So I will write minus NB, and the perpendicular distance of this NB from that point A is this 26 square minus D square under the square root. And this weight is producing the counterclockwise moment like this. So we will write plus, and the perpendicular distance of this weight, if we extend the line of action of this, so it will intersect this OA length at its midpoint, and then this perpendicular distance from point A is D divided by 2, the half of this. So I will multiply this with d divided by 2. And now NV, this is d divided by 2. Now NB is equal to 0.3 times NA, and A is known. So if I put this NA in this equation, we will find NB value. So now I can find NB equals to 0.3 into 30. This will give us 9 pounds. So NB is equal to 9 pounds. I can substitute this NB equals to 9 pounds. So let's write that this is 9. And this is equal to 0. Now minus 9 into 26 square minus d square under the square root, and this will become minus into d divided by 2. Minus will cancel out, and this 30 divided by 2, this is 15. So let me write this as, this will become 15d. So we can say that this is we are having the equation like this now. This is 15d. This is 15d. And now if I divide both sides of equation by 9, so this 9 will cancel out, and we will have 26 square minus d square under the square root equals to 15 divided by 9 into d. Now taking square on both sides, so this will be this square will cancel out this square root, so we will have 26 square minus d square equals to, and that 15 divided by 9 square, that is 15 divided by 9, this gives me 1 point, this is square, right? So this is in fraction, this is 25 divided by 9 d square. Now if I bring this d square term to the other side of equation, so we will have 26 square equals to 25 divided by 9 d square plus d square, and now we can write that 25 divided by 9 plus 1 into d square is equal to 26 square, and 25 divided by 9 plus 1, this gives us 34 divided by 9 d square equals to 26 square. And now from this we can say that d square is 9 into 26 square divided by 34 if we cross multiply this. So 9 into 26 square divided by 34, so we get this. And now if we take the square root on both sides of equation, so we will get d value. So now d value is square root 9 multiplied by 26 square divided by 34. So d comes out to be 13.38 feet. So now if you want to have the pole and its position when we release it, so then this d, the distance of this point A of the pole from that point O, must be equals to 13.38 feet. So that d solution is 13.38 feet. So this is the solution of this particular problem. Let me know in the comments if it helps in your learning, and do share this video and my channel with your friends so that we can reach out many more students like you people.